here 3x plus 2. But we can't leave y with the 2, so we've got to divide by the 2. Remember, everything gets divided. You're left with y is greater than or equal to 3 over 2x. And then 2 divided by 2 is 1. So that's what we're graphing, and this is what we're graphing. So let me write that down before I switch slides. Alright, so back to my lovely grid paper here. I'll see, this time it stayed. Okay, so let me clear the board off. Alrighty, here we go. So let's graph the one that we just rearranged. We have 3/2 x plus 1. That means we've got an intercept at positive 1. So there's my point. I got a slope of 3/2. That means I got to go up 3, then right 2. I could also have gone down 3, back 2. So there's my dots to set up my line. But now, what kind of line do we have? My inequality, if you remember, was this right here. Okay? This symbol tells me I need a solid line through those dots. Alrighty, now we get a shade. I don't want green, so let's go, how about peach? Y is greater than that line. So where is the top of the line? Where is it greater than? Well, hopefully you're catching on that the greater than region is going to be up here. Okay? Now we need to graph this other line that we had, which was y is less than 4x plus, oh no, there, we found it. Y is less than 4x plus, did it again, plus 3. I'm going to put that plus 3 down here because I'm clicking something, it's making it move. Okay, so y is less than 4x plus 3. So let's go ahead and get this on the graph then. Positive 3 is my intercept, so I need to go up on the 3 on the y-axis, get my point plotted. Okay, my slope of 4 means I got to go up 4 over positive 1. Could also have gone down 4, back 1. Okay, so we need to connect it now, but this one's going to be a little bit more tricky just because we're running into the other one here. What kind of line am I going to have based on that? It is going to be a dashed line. It does not equal. So if we dash this line, hopefully you can see that, and hopefully you'll see how easily these things are to start getting like mixed up and stuff. Okay, so now we need to shade. Alrighty, so y is less than the line. So if I look at that dashed line, what side of it is going to be less than? Well, that's going to be the region right over here. Alright, so remember, the solution to this system is the area where the two colors do the overlapping. So let me bold that part up. So you could give me any coordinate point in that solution or in that area, that red box, and that will work for the system. Now if it asks for two solutions that are like two answers that are not solutions, you can choose anywhere else on that graph and it will work. Okay, so hopefully you don't have any questions as of now. Alrighty. Alright, so last but not least, we have three more examples to look at. Okay. Alrighty, so we've also looked at, before when we dealt with equations, we saw that if lines were parallel, that there'd be no solution because they never crossed. Well, with the systems of linear inequalities, it's not always true. It's all based on where the shading occurs. So we've got a couple here that we're going to look at. Notice the first one, y is less than equal to negative 2x plus or minus 4. The second one, y is greater than negative 2x plus 5. So if you notice right off the bat that the slopes are the same. So that's what they were saying, like with the equations that we've done, we would know right away that because the slopes are the same, they're never going to intersect. Well, that still holds true here, but we need to see what the shading is going to do and to see if that would create an ability to have solutions on this one. Okay, so the first one we're going to graph is y is less than equal to negative 2x minus 4. Alrighty, so that minus 4 tells me that I have an intercept down here at negative 4. Okay, and my slope is negative 2. That means I go down 2 over positive 1. Could also have gone up 2 back 1. Alright, what kind of line do I have? That's an equal bar there, so that means my line is going to be solid. Solid right through those points, hopefully. Okay, now let's shade. What side of this line is y going to be less than? Well, hopefully then you are saying that the bottom of it, there we go. So there's the first one done. Next one is y is greater than negative 2x plus 5. Alrighty, so let's start by graphing it. We got an intercept at positive 5. Clear up here. Slope is negative 2, so down 2 over 1, down 2 over 1, down 2 over 1. Okay? Based on my symbol, I know my line should be dashed. Okay? And then we have the fun time of shading. Alrighty, so on what side of the line, the red line, is that y going to be greater than it? Well, if you said the top, then you're good. Alrighty, so this problem's done. Notice, does my shading ever overlap? No, they do not. So because of this, my lines were parallel. My shading does not overlap at all. This equation, or this system of inequalities, technically has no solutions. Alright, so you'd have to graph that to see that there are no solutions. Alright, hopefully no questions there. Let's move on to the next one. The 3x. So back to my lovely grid. And let's see what happens with this one. We've got y less than 3x plus 6. Alright, so now to graph. Got an intercept at positive 6. 1, 2, 3, 4, 5, 6. About right there. Slope of 3. So that means I can go up 3 over 1. Could also have gone down 3 back 1. The symbol here tells me my line needs to be dashed. So you just do your best to dash it. Hopefully yours looks better than mine. And then we've got a shade. What side of the line is y less than that? Well, that's going to be on the bottom side of it. So it's this side over here. Alrighty, so the next one we have y is greater than 3x minus 2. So let's start with that intercept of negative 2. Plot a point at negative 2, which is right here on my screen. Up 3 over 1. Down 3, back 1. Okay. This symbol tells me I need a dashed line. Alrighty, and then to shade it, what side of that line is y going to be greater than all of it? Well, that's going to be on this side. So notice, even though my two lines that we plotted were parallel, based on what the symbols were, we were able to create a solution region. So the region in the middle between the two lines, if I can kind of bold it up here, any answer inside in between those two lines would be a solution to that system. So yes, even though they were parallel, the solutions are all the points between the parallel lines. Awesome. Alright, one more, and then I'll let you guys get busy with your work here. So there's your problems. They're on your worksheet. I'm going to go ahead and go back to my graphs paper real quick, and let's get these things started. First one is y greater than equal to 4x plus 6. Okay, so we've got an intercept at positive 6. 6. Slope of 4 means up 4 over 1, or I could go down 4, back 1. Alrighty, the symbol here, it's equal to, so we know my line is, that was bad, solid. Now to shade it, y is greater than, so we're shading this side of it. Next line, y is greater than equal to 4x minus 5. Okay, so we're going to go down to negative 5. Plot your starting point. Okay, slope of 4 means up 4 over 1, down 4, back 1. Symbol here tells me my line is solid. Okay, hopefully I can get this where my graph's kind of looking like it's going to be, it needs to be parallel. So just imagine those two lines are parallel. I apologize for the bad drawing. And then on what side of the line is y going to be greater than? Well, greater than is going to be on this side. So notice it doesn't overlap here, but when I continue my shading, it overlaps over here. So my solution region is going to be any ordered pair in this region. So there you go. Alright, you guys are good to go. Hopefully you have all the notes that you need to get this section completed. This will flow over into Wednesday if you're not already watching this on Wednesday. So best of luck. Get your guys' work done. You're following up with a review sheet tomorrow followed by a test on Friday. So do your best. We'll get this stuff out of the way and done.